In this topic, you might want to jot down just a couple of things in your notes. One of them is what symbols go together. If you have a plain less than, and remember one way to read that is if you open up that symbol, it makes the letter L. So the one that makes an L is less than. The one that does not make an L when you open it up is greater than. If they are not underlined, it's the same thing as an open dot. And then another notation that is the same thing as an open dot or less than, greater than, is a parenthesis. Then for our inequality symbols that are underlined, less than or equal to, greater than or equal to, those go with a solid dot. But another notation that means the same thing as the solid dot is a bracket. Then the one extra piece that's not up there to keep in mind is if you are describing numbers that go on forever to the right, that's positive infinity. And if you're describing numbers that go on forever to the left, that would be negative infinity. And the symbol that goes with both negative infinity and positive infinity is always a parenthesis. Okay, so if we put that in action here, graphing these inequalities is a bit of a review. So when I am wanting to graph, when you read this, these little squiggly lines like that, you say the set of numbers X, then you have this long line right there and you read that such that. In some textbooks you'll see a colon, like two dots like that, but they both are read such that. So the set of numbers X such that my numbers X are less than 3. So we're going to, because that's not underlined, we're going to take this open dot and we're going to place that at the number 3. And then if our numbers are L less than 3, numbers that are smaller than 3 on the number line are to the left. So here's my arrow going to the left. Now we have this currently in what's called set notation, and we are going to turn it into what's known as interval notation. And when you're creating interval notation, you want to list things just like you would read a book from left to right, or if you were advertising a camp for kids ages 8 through 12. You wouldn't say ages 12 through 8. So you always want to be small to large. And so on a number line, the smallest numbers are on the left and the bigger numbers are on the right, which is why we want to list them from left to right. Okay, so we're just going to translate that. Over here, the description of numbers that go forever to the left, that would be negative infinity. And the symbol that goes with an infinity is a parenthesis. So I'm going to go parenthesis, negative infinity, comma, okay, which just means through. Now, keeps going, keeps going, keeps going, and I stop at the number 3. So I'm going to have a 3 here. And then I have to decide if I'm going to close this off with a parenthesis or a bracket. And since it's an open dot, that's going to be a parenthesis. And so this is just indicating every number as far left as you can go up to the number 3, but leaving out the number 3. So 2.9999999 is a solution. 2.999999999 is a solution. But as soon as I get to the number 3, the number 3 itself is not a part of the answer. Okay, so let's look at just a couple more here. Okay, this one in set notation says the set of numbers X such that X, this one does not make an L, so greater than or equal to -4. So because of the underline, I'm going to take a solid dot and place that at -4. And then numbers that are bigger than or equal to -4. Numbers that are bigger than -4, numbers that are bigger on the number line are to the right. So I want my arrow going to the right. So I have my inequality graphed. Now when I turn that into set notation, we're gonna read it from left to right. So the first thing we come to is -4, and it's a solid dot. So the symbol that goes with the solid dot is a bracket. So we're gonna have bracket -4. And then through, so we go comma. Whoops, sorry about that. Okay, comma. And then we're going forever to the right. And so the symbol that is forever to the right is positive infinity. And then we have to decide on how we want to close it, but infinities always go with parentheses. And it's because we can never actually, it's a concept, not a number to go and capture and stop at. It just, we're never quite getting there. That's why we have that parenthesis. Okay, so one more example here. So this one here says the set of numbers x such that our x is sandwiched between -2 and 1. Or -2 is less than or equal to x and less than 1. Or the set of numbers x such that our x is bigger than or equal to -2 and x is less than 1. But when you see that x sandwiched in the middle, that means your numbers are sandwiched in the middle of two numbers. So the two numbers they're sandwiched between is -2 and 1. And at -2, because of the underline, I'm gonna go ahead and put a solid dot there. And then 1 does not have an underline, so I'm gonna put an open dot there. And then my x is stuck between those two numbers. Okay, so we're gonna attach that like that. So numbers that make this true are -2, including -2, through 1, but leaving out the number 1. So if we use interval notation to describe that from left to right, the first thing I come to is -2 at a closed dot. So I'm gonna have my -2, but the symbol that's gonna start that off is a bracket. And then we have through, so comma, and then we keep going until I get to the number 1. And then the symbol that's gonna close that off, because it's an open dot, is a parenthesis. And hopefully, even though I haven't done this particular example, let's say that this one was an open dot and this one was an open dot, then that would be a parenthesis and this one would be a parenthesis. And then it is parenthesis -2 comma 1 parenthesis, which looks like a coordinate, like you go plot a point at back 2 up 1. So I'm just saying that out loud to kind of put that in the back of your mind, that just because you see a parenthesis, a number, comma, a number, close parenthesis, it doesn't mean it's a point on a Cartesian coordinate. It might be in the context describing what x's you can use a number through a number.